Hello everyone. In this video, I'm going to share with you about the cumulative distribution function of the random variable for discrete and continuous. And in video, I'm going to cover about the definition of CDF for both discrete and continuous. And along with that, the properties and remarks are needed, so it will be discussed. And in the problem solving, I'll cover in examples about how we can calculate the CDF when the probability distribution function is available, and how we can find out the probability of the different situation of the random variable using the CDF formula. We have already calculated how to find the probability using the probability distribution function, but now we will use the cumulative distribution function for that. So that's an important point to learn. And we will also share how we can plot the graph of the cumulative distribution function and two examples. So in all the examples covered both discrete data as well as the continuous. And in one case, I'll also share with you that how we can retrieve back the probability distribution function if the cumulative distribution function is available. So let us begin with the first concept in terms of the definition. So the first definition, let's see what it is. The first definition is talking about the discrete data. So what we need to learn, there is a notation part. The capital Fx is the notation for the cumulative distribution for both continuous as well as the discrete. We know that the small fx we are maintaining for the probability distribution function. So how we can calculate it? What is the definition? So the cumulative distribution function fx for the discrete random variable with the probability fx is what? So fx is equals to probability of x less than equals to x. What does it mean? It means I am looking for all the probabilities which are having value x and less than x. So it means if there are some probabilities which are having less than x value, we will add them, right? So in this case, we are going to write a formula that sum of all the probability distribution of x means all t's which are either less than or equals to x. Let me share with the help of the situation. For example, the discrete data has this random variable x1, x2, x3, x4 and so on, let's say till xn. And I am looking for what is the cumulative distribution function for this random variable x3. It means definition wise I am looking for what is the probability of x less than and equals to x3. It means I am looking for the sum of all the probabilities of t which are less than or equals to this t which is less than x3. So it means I have to take the points between x3 and these are the entries. So I have to add the probability of x1, probability of x2 and the probability of x3 in the calculation of the cumulative distribution. In the continuous, we have the same definition remains same, only the addition pattern will change. So here also I am looking for example, if let's say this is a graph, because continuous has this graphical presentation, and minus infinity to infinity we have plotted the graph, and let's say I am looking for this point x and what is the cumulative distribution function for this x. So it means I'm looking for the probabilities x less than equals to x. Since in the continuous every point is the participant, it means I'm looking for this portion, right? And that means I will integrate from minus infinity till x all the probability f of t. So that way we can calculate the cumulative distribution for the continuous. And there are some important properties and results which are useful for the problem solving. The first property says that this cumulative distribution function is a non-decreasing. What does it mean? It means if x1 is less than x2, like if this is a x1 and this is an x2, if it is less than, then we know that the cumulative distribution because for x1 you are adding the previous entry, but for x2 you are adding all the previous to it. So it means the f2 value, f of x2 value will always exceed the previous one, and that will make it a non-decreasing function. The second property says that cumulative distribution function for minus infinity is 0 and for plus infinity. Third property says, now this is one of the important property because it will help us to evaluation of the probability at a point for the discrete. So that is for, this is used for discrete and this we will use for continuous. Now this says that if we have the random variable in this manner, I know that this xith value is just next to the xi minus 1. Now if I want to find out the probability of xi, this number, how I can use the cumulative distribution data? I will calculate the cumulative distribution till x1, xi, and since the previous term is not including xi, so I'll subtract the sum till this number, and this manner we can calculate the probability at any point, any random variable. And what happen in case of continuous data? If the random variable is continuous, we know that this capital S we are obtaining by integrating this PDF, and if we want to retrieve back, we can differentiate it because they are of inverse process. So we can get back our PDF function by differentiating this function, provided it is differentiable. And the fifth property says that the range of the cumulative distribution function is always between 0 to 1. It will not go beyond it, right? Now, there are some more results, but before that, let us discuss some questions that whatever we have discussed so far, let's try to cover that portion. So I have taken here the first example. In this first example, the discrete data is given. Random variable is discrete by nature because we can see that x is listed here and it has a corresponding probability, and we have to construct the cumulative distribution function. Now, there are 2 points we have to take care. So what is the step 1? So because we have to write down the cumulative distribution function for both the cases, whether it is a discrete or it is given in terms of the continuous, every time you will observe it is written in terms of an intervals. So what is the step for the discrete data? The step number 1 is, let us first calculate the fx values, right? We can directly do it over here, but for the first case, let us do it separately. This is given to me 0, 1, 2, 3, 4. The corresponding probability is 0.41 for 0, 0.37 for 1, 0.16, 2, 0.05, 0.01. Now in the next row, I am going to calculate the corresponding cumulative, that is a distribution. Now let's solve first 2 cases using a definition, then things will be clear. What do we mean by F0? F0 means probability of x less than or equals to 0. It means we have to sum all the probabilities which are equal to and less than. I know that there is no x less than 0, so it means only f of 0 will be added, because when we are finding, we include the point. So f0 here is only 0.4, so we have only 1 point. Now if say somebody is looking for what is f1, it means I will find probability of x less than or equals to 1. It means I will take the sum of all the probabilities, which is here t is less than or equals to 1. I know that less than or equals to 1 are the 2 points. F0 is also less than and it equals to 1. So these 2 probability will be added. So I'll add 0.41 to 0.37 and we'll get the cumulative distribution value for 1, and that's turn up to be 0.78, right? And for next one, now what we are going to do is, we got an idea, but directly we can calculate it. The step number 1 is, you just first number will be dropped down as it is. Now 0.41 you can add in the next value below 1 and add, you will get a 0.78. We have already added value of the first and 2.78, so we do not need to calculate every time for the 2, 3, 4. Already the total value before 2 is given to be 0.78. I'll add it to the 0.16. It will give me the cumulative distribution for 2, and that becomes 0.94. Now till 294 is there, 0.94. When I will add, I'll get the cumulative distribution for 3, which is 0.99. And this 0.9 when added to the 4, we'll get it 1. We always get it 1 in the last term in case of the this discrete data. Now Next step is, this is a step 1. The next step is how to write the CDF of x in terms of interval. That means we have to look for that in question there is a 0, 1, 2, 3 and 4. But if I want to enter in every real number, how we can write down in terms of the function? We know that the probability is only existing for these 5 numbers, but how we can cover all the points? If somebody is looking for what is a cumulative distribution for this function, for this value, means every real number, if it is part of the discussion, how we can calculate it? So for that, what we need to do is, let's see what is the first number of this data, 0. So we'll say when x is less than 0, this is equals to, just a minute, when x is less than 0, we have no value behind, so it will be 0. Now when x is more than 0 but less than 1, why we are writing less than 1? Because I know that till 0 the sum of the probability is 0.41, so I have this 0.41. Now why am I stretching it to the 1? I know that the next value frequency is probability is for 1. That means any number between 0 till 1, before 1, has no probability, so it means they have a 0 0 0 probability. So whether you are adding the probability of any number from 0 before 1, they have no contribution. It means the f of x value will be always remain same, because only 0 is the probability existing so far. So we can write in terms of the interval, means we can entertain every real number over here. So in the same manner we can write down, so 1 less than 2. So less than 2 means we have a 0.78. It means if the number, any number is here, anywhere here, I know that till total probability 1 is zero point 0.7. Whether you are asking me this point, there is no probability, so you are adding 0 to that, and it can happen before 1, 2, because the moment 2 will come into the picture, it has some probability, it will be added and it increase the value. So we will maintain it less than 2, and so on. We can write down when x is greater than or equals to 2 but less than 3, then it is equals to 0.94, and when x is greater than or equals to 3, less than 4, the value is 0.99. Right, so we can enter in, because they any number which is more than 1 but less than 2 have no probability, so it means it will be 0. It means the sum before that will be remain the same constant answer. And the last one is when x is greater than or equals to 4, it will be 1. Let's say if somebody say what is a f of 5, f of 6, f of 7, f of 8, I know that f of 6, 5, 7, 8, whatever is the point here ahead of 4, have only the probability behind these for 0, 1, 2, 3, 4, and we have already added and the value is in 1. So we don't have any probability after that. So it means if you keep on adding 0 to the previous entry, it will be maintained at a 1. So 4 onward, everything gets stable and we get the answer. Right? Now we want to plot the graph. So for graph, I have taken the second example. Here already the cumulative distribution function for this given problem, and we observe that the fx is calculated for these 3 values in terms of interval. Now when you are plotting it on a graph, so what we need to do is we write down all the discrete values. Here in the data 0, 1, 2 is there, so the step 1 is write down all the values 0, 1, 2. The second is when x is less than 0, the sum is 0, so it means we are just making it a little bold, so it is 0 here. The moment the value take the 0, it will jump to 2.2 by 7, and this will be same as what? 2, because there is no probability in between 0 to 1. So it means the sum of the previous entry will be constant as a 2 by 7. But the moment, that's why we have highlighted the lower bound, lower value of the line. The moment it is 1, because we are not entertaining 1 here, the moment x become 1, this value when added to its probability, it will jump to 6 by 7, and this will continue as it is till we are behind the 2, because the moment it takes 2, it will jump to the next one, and that way we can get a step function, and after that it will be 1. So this is a process because here what we are doing, the information is in discrete. We have calculated the cumulative distribution function for every point. Now we can enter means cover whole real line to write the sum. So it means if anybody is interested to find what is the total probability behind this real number, so you can make use of this CDF and you can calculate it. Now let's see one question for continuous data, right? Here, this is a question. This question is using some information of the previous problem, and that's why I've mentioned both of the problem taken from some book. We want to find out the CDF. Like first we have to find CDF, we have to draw, and one more case we have to evaluate using that CDF. So this part I'll do later on because one result is to be discussed. So let us cover the first and two part. The first part is to find a cumulative distribution function for the continuous random variable. So first let us see how this is defined because this is given in terms of the statement. So when we write down in terms of this expression mathematically, f of x, they are saying a continuous random variable can assume value between 1 to 3 has a density function 1 by 2. So it is given as a 1 by 2, a constant value when your x is between 1, 2, 3 and 0 otherwise obviously, right? So in this manner we get this is a PDF. Now what do I want? I want to find out the CDF for it. So let us recall the formula. F of x is equals to probability of x less than or equals to x is equals to minus infinity to x integration of the probabilities dt. Now when we see this question, I know that in this question different intervals are there. There is a minus infinity to plus infinity, and we see that when our interval is between 1 to 3 there is a probability value constant, but before 1 it is 0, after 3 it is 0. Now it means we will find out the sum for means at a different stages. My first case is when x is less than 1 because it is a 1. They bifurcated into three intervals: this first interval, second interval and the third interval. In the first interval, x when less than 1, I know that there is, because we are adding all the frequency, it means formula wise if I go, I have to find out f of x. That means the formula says integrate minus infinity to x, because x is less than 1, it means x anywhere from minus infinity to less than 1, I have the frequency of 0, means probability 0. So it means integration of 0 will be remain 0. So we get f of x as a 0 for this interval. Now the second interval says when your x is greater than or equals to 1 and let us maintain is less than 3. What will happen? In that case my f of x is equals to, again we will do the same problem, infinity to x f of t dt. Now here very important point to learn. When we are writing the formula, we'll go back and see that right now my x is more than 1 and less than 3. So x can extend it to 3. So I want to make the upper limit as an x, lower limit as an 1. Why? Because before that we have to write down the function from minus infinity. So whenever we are doing next interval, how do we write down? We write down this interval full from minus infinity to 1. We write down what is the function which is given to me 0, plus then I will start from 1 because right now my x is somewhere here. X is here, somewhere here. So for that, how do I write the CDF formula? Whenever the current interval is the participant, you write the lower value 1, right? Here we are writing 1 and the upper value as a variable. Why? Because we are looking for the formula for CDF between 1 to 3. So we will always write the upper limit as x because it is changing. It can take any value. And we will write down the function which is available in the problem. So in the question it is given to me half. So I will write down half and integrate it. So we know that this is not giving me anything, only integration is for this part, and integration of, you can write it like t, let it be t, right? So integration of half times dt is t from 1 to x, and after simplification we get upper limit as a x, lower limit as a 1 divided by 2. So that become my next interval. What about the third interval? In third interval means when x is greater than or equals to 3. So in that case, I'll take minus infinity to x f of t, and I know that from, so here what do? We integrate from 0 to 1 and 1 to 3, means from 0 to 3 we are going to integrate, and we know that from minus infinity to 1 there is a function, from 1 to 3 I'll use the function dx by 2 plus I write down x to infinity, sorry, 3 to x. I know that 3 onward it is 0, and here it is also 0, and we know that x that will be x upon, let's take, every time I'm writing it as x, you can write x also, it's okay, 1 by 2 t 1 to 3, that is 3 minus 1 by 2, which is equals to 2 by 2 is equals to 1. So we know that after that it will be constant. Even we do not see here I have integrated, but the moment you get the last interval it is always 1. So we can write down the function like that. F of x is equals to, so there are three intervals, x less than 1, x greater than or equals to 1 and less than 3, and x greater than or equals to 3. Here we got 0, here we got x minus 1 by 2, and here we get a 1. So in this manner the CDF function is evaluated. Now we want to plot it. So how do we plot? The same manner what we did in the discrete. So we will write down, we jot down all the points, 1 is here, 3 is here. So before 1 it is constant, so it will be 0, this will be 0, line is 0 here, right, till infinity. But the moment it is 1 till 3, this is x minus 1 by 2. I know that x minus, this is a straight line, so the two end point of the straight line is 1 and 3. So when I put 1, I'll get 0, this point on the x-axis. When I put 3, it will be 2 by 2, which is 1. So it means, let's say if it is a 1, so it will go till here, and we can join the line, right? This line is joined, and after that it will be constant. So this is a CDF for this particular question. There is a one more problem, which is use it to evaluate probability of x between 2 to 2.5. We know that this can be evaluated with the help of the probability distribution function, but currently we are focusing over how to evaluate all these kind of probability using a cumulative distribution function. So for that, let's have a quick glance over some formulas. These are important formula. These formulas can be utilized for the calculation of the probability in an interval form if it is given. So the first one is for the discrete I am discussing at the moment. The first property is saying when the probability is in between A to B, where the upper limit is included, lower limit is not included. So in discrete data it matters, equality matters over here. So what will be the formula? We have to remember this formula. Whenever upper limit is included, lower limit is not included, in case of discrete, we can write down the cumulative distribution value at B minus cumulative distribution value at A, the lower value. If x is a continuous random variable, then equality doesn't matter whether you include the endpoints or you not include the endpoints, because end value single point has probability 0. Let's do the third part, which is asking find the probability of x between 2 to 2.5. So we have to use the cumulative function, distribution function. And we know that in continuous, it doesn't matter whether endpoints are included or not. So as per that, we have to find out f of 2.5 minus f of 2 means b minus a. And we know that 2.5 is also here, 2 is also between 1 to 3. So we are going to plug in the value, because then we get a formula, and if somebody is looking for f of any point, we can see where it is lying and plug in the value. So we have a 2.5 minus 1 half, and this is 2 minus 1 half, and that will be 1.5 half minus half, which is 0.75 minus 0.5, and that is equal to 0.25, and which is nothing, a 1/4. So in this manner it can be calculated. Let us see a similar question in case of the discrete data. Means we have to calculate, because they have given the cumulative distribution function and we have to calculate all the points. So here let us see one by one. I have already calculated. This is a PDF calculated and this is a CDF. But we will like to calculate rest of the term using the formula. As you remember, we discussed this formula initially, which is in the properties. We saw that if we want to find the probability of the discrete data, we see the frequency, the cumulative frequency at that point minus the previous. So we are going to use the same thing here. If I want to find out the probability of t is equals to 5, how do we calculate it? So I'm going to find out it f of 5 minus f of 4. Now we will see from this table, because it is a discrete data. So f of 5 is here, so it will be 3 by 4 minus 4 is here 1 by 2. So 3, 4 minus 1 by 2 will be 1/4. So we get this answer. Now one more point I want to discuss here. Remember, whenever we want to find out the probability greater than, strictly greater than, remember that this total probability is 1. This greater than can also be calculated by writing probability of t less than or equals to 3. And I know that this is nothing but it is f of 3, and we can see from the formula what is f of 3. F of 3 is here, so it will be 1 by 2. So 1 minus 1 by 2 is 1 by 2. So it can be calculated. Now you can see this is the discrete data, and I've shared with you that whenever we want to write on, let me make the form. Here I have to write on 1.4 less than, lower limit is less than needed, it is already there. We can include 6, and we will also subtract the probability of 6 here. And you can see that there is no, t is not equals to 6, so probability is 0. So it means for the substitution here we have a f of 6 minus f of 1.4, and this value is equals to actually 0. So we don't have any contribution for that point. So we will see what is f of 6. 6 is lies between 5 to 7, so it will be 3 by 4 minus 1.4. 1.4 is in this second interval, and the probability CDF is given as a 1 by 4. So when we are calculating, we can write down this is half, right? Now in this case, the third one, what do we need? We can see that this is here, I need a formula. Let us write down the probability of A condition that B is given is equals to probability of A intersection B divided by probability of B. So here I have to find out the common point. So how do we calculate it? We are going to solve it like, now it means here the situation is there is a point 2, there is a point 5. We are saying the common point between them, t greater than 5. T greater than 5 is, sorry, t less than 5 is in this side, and t greater than or equals to 2 is this side. So we have to find the common point. So this is a common part of it. So it means the common part, if I write in terms of a probability, it is equals to t greater than or equals to 2 and less than or equals to 5 divided by what? Probability of t greater than or equals to 2. If I go as per the formula, how do we write down? I know that in this case, because it is a discrete data, so if I go as per the formula, I will separate the probability of 2, and then the lower limit is included, so I write down f of 5 minus f of 2, right, divided by, this is 1, because here you are looking for greater, so 1 minus probability of t less than 2, right? So here we can observe that because f of 2 is still not here, so that, sorry, probability of 2 is not here, so it will be 0. So in my case, f of 5 minus f of 2 will be maintained. So what is f of 5? F of 5 is 3 by 4 minus f of, what we need, f of 2. F of 2 is 1 by 4. Here 1 minus, I need a probability of equal to also. So if I, in this case, I include and separate, means that will be written in terms of a f of 2, and also if I want to if I subtract f of p of 2, which is again 0. So in this case we are observing there is a jump of the entries, so they are not contributing anything, and we can find it directly. But right now we should remember how the formula can work, and that is equals to, in this case I will write here 3 by 4, 1 minus 5 f2 is again equals to 1 by 4. So 1 minus 1 by 4 is 3 by 4, and here 3 by 4 minus 1 by 4 is 1 by 2, and we get 1 by 2. Denominator will be 3 by 4, so that will be 4 by 3, and the answer is 2 by 3. So that will be the answer. I would like to share here, because in the previous question we were not facing any situation where that specific formula is to be needed. You can see from this problem, this is similar like that, 1 minus probability of w less than or equals to 0, because here the data is given, PDF is given, CDF is given, we have to evaluate it. And what we will do, 1 minus f of 0. 1 minus f of 0 means 1 minus f of 0 is here in the third interval, which is 7 by 28, it's 27. 7 by 27 means 20 by 27. Now here we have to pay attention for this question. You can see in this question it's a discrete data, right? And we know that if I want to use, they are saying using CDF. So if I want to use CDF, what I need? First of all, I'll separate it. Let me first separate because lower limit is not needed. So I am going to write down W is equals to minus 1 separated. And here I am writing probability of minus 1 strictly less than, W is greater than minus 1. But it should include the upper limit. So I'll include 3. So side by side I'll write on probability of W is equals to 3, because I have included, so I'll subtract. It's minus here, right? So now we can write down here P of minus 1 minus P of W is extra, and then the substitution for this is using the CDF, F of 3 minus F of minus 1. So now we know that what is the probability of minus 1 is 2 by 9. Probability of, why I'm writing W here, it's 3. Probability of 3 is 8 by 27, plus F of 3 is 1. F of minus 1 is 7 by 27, not 28. So it is all a solution. So let us see if we take an LCM. So 27 is an LCM, and we have this part is a 20, so we can write on 20 by, this part will be 20 by 27, so I can write on 20 here, and when we write on here 8 minus 8, and when we simplify it, so we get this 3 to the 6. So 6 minus 8. I know that here it will be 18 by 27. 18 by 27 means 2 by 3. So 2 by 3 is the answer for this question. So this question is specially taken, keeping into mind that substitution. Now this question was when CDF was given and we are calculating all the probability and we have calculated the rest. Now let us consider the last question. Here I have taken a continuous data, and in this case CDF is given and we have to calculate the some question related to it. So they are saying the waiting time in hours, right, between the successive speeder spots of the radar in a continuous random variable with the cumulative distribution function is given to us. They are saying find the probability of waiting less than 12 minutes between the succession, and using the cumulative distribution function of x and using the probability density. So both is in the demand. So let us first find out the first part, that is a probability of x less than 12 minutes. Less than, waiting time is less than 12 minutes. I know that in this question the x is representing in hours, so we have to convert it into hours. So that means probability of x is less than 12 by 60 hours. That means probability of x is less than 0.2. And we know that using the cumulative distribution function, probability of x less than, because in case of the continuous data, it will be remain as f of 0.2, because whether equality sign is there, less than or equals to, in terms of the f of x. So it will be f of x is 1 minus e to the power, because 0.2 is in the second interval. So we are going to write on 1 minus e to the power minus 8 times 0.2, which is equals to 1 minus e to the power minus 1.6, and that is equals to, after simplification using the table value, we can get the answer as a 0.7981 if calculator can be used for that. Otherwise we can leave answer here if calculation is not possible. But the second part of the question is also that use the probability density function to evaluate. So it means let us first find out the f of x. That how do we find f of x? F of x means we will take a derivative of capital F of x, and the derivative of capital F of x means here 1 minus e to the power minus 8x. So when we take a derivative, it will be 0. That become plus 8 e to the power minus 8x when x is greater than or equals to 0. So we are getting f of x is equals to 8 e to the power minus 8x when x is greater than or equals to 0, otherwise 0. So that will be our distribution PDF. And in that case, if I want to find out the probability of x less than 0.2, that means I'll integrate minus infinity till 0.2 this function, which is 8 into e to the power minus 8x dx, and we'll say the integration of e to the power minus 8x is divided by minus 8, and when we will limit 0 minus infinity to 0.2, 8 and 8 will get cancelled, and we'll get minus of e to the power minus 8x from 0 to 0.2, that will be equals to 1 minus e to the power minus 1.6, which is same as our previous, only we wanted to use the PDF for that. So we learn how to calculate PDF. I hope you learn this topic. Thank you.